Hello my dear students, I welcome you to NEET World. So we will be discussing EAPCET 2025 21st May shift question paper, shift 1 question paper. So here we have questions, few questions from that paper here I have collected. So just look here, the question says at a temperature T Kelvin, the solubility product of AgBr is 4 into 10 power minus 13. So what is its solubility in 0.1 molar KBr solution? So this question is from which topic it is? Solubility and solubility product, which we are studying in equilibrium chapter, right? So what happens here? One of the very important topic, you will be seeing questions, this kind of questions in JEE, NEET and EAPCET, okay, in other entrance exams also. So let us understand this topic once. So here solubility product of AgBr. So AgBr is a sparingly soluble salt. So whenever we place this AgBr in aqueous medium, so what happens? Some extent of this whatever the salt given, that will dissolve to some extent, solubilize to some extent. After that it will be having equilibrium with its undissociated molecule. So initially it will be like this. Whenever we kept in the water, so some amount will be dissociated like this. So after dissociation, these whatever the dissociated ions are there now, so those ions are recombined to form this molecule. That's why I have represented equilibrium symbol here. Okay. So now this is a condition where I can say it is saturated, forming a saturated solution. So in saturated solution what happens? So if this is a S is the concentration of solubility or the concentration we have taken for this particular AgBr. Now initially at time 0 T0 we will be having S here and this will be 0 0. So after some time what happens? After some time what happens? So after some time T, okay, so from this some amount will be solubilized. So I am writing S into S. So now KSP, solubility product for this will be taken as concentration of Ag plus into concentration of Br minus. This is what you need to consider here. So what is the concentration of Ag plus S, and here it is S. So this is how you need to take. KSP will be S square you can write. Okay. So this will be the scenario when there is no common ion effect. But here we have this AgBr we are solubilizing in presence of 0.1 molar KBr solution. So in this case we need to have a little bit different approach using a common ion effect concept. Okay. So what we need to use here? Common ion effect concept. What is that common ion effect concept? So in this beaker where I am keeping this AgBr, like water is there. So in this water, along with water we also have KBr. Okay, we also have KBr of concentration 0.1. So in the same solution I am putting this AgBr now. Okay, it means total concentration of Br minus here will be equals to what? Concentration of Ag plus Br minus from AgBr and concentration of Br minus from this KBr. So I can write S plus concentration of Br minus, I can write S plus 0.1. So why I am writing like this? So KBr is a strong electrolyte, so which will be giving 0.1 molar concentration for this particular solution. Now what is the resultant concentration of Br minus? This will be equals to concentration of strong electrolyte only, 0.1 only, means Br coming from KBr only, not from AgBr. This is what common ion effect. The degree of dissociation of weak electrolyte will be suppressed by addition of this strong electrolyte. It means its solubility, AgBr solubility will be decreased when we add a strong electrolyte which is having common ion with this weak electrolyte. Okay. So therefore now what happens here? The KSP value here we should take. So solubility product in this case you can take concentration of Ag plus, okay, concentration of Br minus. So what is the concentration of Ag plus? Let us say it is S. Okay, solubility is S. For Br minus it is how much? 0.1. Okay, so this is in presence of common ion now. So let us say this is S dash. Okay, so let us consider this is S dash in presence of common ion. Okay, so now KSP value is how much they have given in the question. So 4 into 10 power minus 13. Here it is S dash into 0.1. So 0.1 I am writing it as 10 power minus 1. So this and this if I remove we will get 10 power minus 12. So what is the solubility of AgBr in presence of common ion? 4 into 10 power minus 12. Very easy concept. right? So this is what our answer. So here we have option number 3 as like this, 4 into 10 power minus 2 is our answer. Hope it is clear, right? So now if you wanted to study more and more in detail about this particular topic, I have made a dedicated video on this particular session. I mean solubility product, that is what equilibrium chapter. I have made 2 or 3 videos on this particular chapter, so you can go and watch in our playlist. Okay, everything clearly explained. So once after watching this, you can do this kind of questions very easily. Okay, without having no confusions, you can do questions easily. Okay. Next, what is the electronegativity, the order of electronegativity of boron, aluminum, indium, thallium? So how can we give this? So they are saying this is the order. So is that correct? Boric acid is a weak protonic acid. Boric acid is a weak protonic acid. Tell me. So tell me, is it protonic acid? Boric acid means what is the formula? So H3BO3. So H3BO3 is a Lewis acid. What is this? It is a Lewis acid. So what do we mean by Lewis acid? So whenever if you look into the structure, you will get more clarity. See, it will be like this. Boric acid will be like this. Okay, so it will be OH, BOH 3 times. It will be like this. This is the boric acid. We can also write like this. So now boron having only 6 electrons around it by 3 sigma bonds. Now there is one empty orbital like this. To this empty orbital, it will accept a pair of electrons. So Lewis acids are those species which accepts a pair of electrons. Okay, any species which accepts a pair of electrons can be considered as Lewis acid. Now our orthoboric acid is which acid? Since it has empty orbital, empty p orbital, it can accept pair of electrons. So I can say this is Lewis acid. So this is not protonic acid. So protonic acid means what? It should donate H plus ion, but it is not donating H plus ion. It is just accepting pair of electrons and showing its Lewis basicity, Lewis acidic nature. So it is Lewis acid more exactly if you want to say, but not this weak protonic acid. Okay, so I can say statement 2 is incorrect, and even statement 1 if you see boron. Okay, after this highest one is boron, after that thallium. Okay, after that we have indium. Okay, after that indium, gallium, and least is aluminum. This is the electronegativity order for this group, 13th group elements. So whatever they have given, aluminum they given more than this indium. So this is incorrect statement. Both 1 and 2 both are incorrect only. So both statement 1 and 2 are not correct. So you can go with option number 2. Hope it is clear, right? Right. Okay. So let's move further. So now tell me which are the following does not exist. So tell me which is not, which will not be existing here. So if you look here, so SiCl4, SiCl6, SiCl4 will exist. Okay, and SiF6 also exists. SiF6 2 minus will also exist. Okay, and but not SiCl4, right? So because of small size silicon, so it cannot accommodate this bulky chloride ions around itself. Therefore there will be repulsions between them and it will not be existing. So which will not be existing? Silicon hexachloride. This SiCl6 2 minus will not be existing. So you can go with option number 1. Hope it is clear. This 6 will not be existing, but this and this can be existed. Okay. So this is not the one which is not existing. So you can choose the option number 1 as your answer. Next, look here. Consider the following statements. Assertion and reason are given. CO is poisonous to living beings. Carbon monoxide. Tell me whether carbon monoxide is poisonous or not. Yes, it is highly poison. Okay, highly poisonous. So how it will be? See, CO. See, when we inhale this oxygen, so that will be binded to the iron present in the hemoglobin, right? So now we can call whenever oxygen binding to the iron present in the hemoglobin, we can call it as oxyhemoglobin, right? So now whenever the CO is also present along with this oxygen in this atmosphere, so what happens? The tendency, the binding tendency of CO, carbon monoxide towards iron present in the hemoglobin is more, okay, and this will form carboxyhemoglobin, not this oxyhemoglobin. Since it is forming carboxyhemoglobin, the binding capacity of CO is more, I am saying now, right. So therefore there is deficiency of oxygen in our body, so this leads to the severe headache and also even lead to the death also, okay. So you can see here CO binds to the hemoglobin forming carboxyhemoglobin, this is correct, which is less stable than oxyhemoglobin. Now this is carboxyhemoglobin which is formed by binding of this CO is highly stable or more stable when we compare with the oxyhemoglobin. So I can say this statement 2, that is reason is incorrect and assertion CO is poisonous to living being, this is correct only. See, A is correct, okay, but R is not correct, right. So your answer 3 will be perfect answer for this particular question. Hope it is also clear. Yes, if it is clear, just click on the like button first. Yes, yes. Now you can feel free to ask your doubts in the comment box. I am looking into the chat box only. Yes. And then next, here we have consider following reaction sequence, okay. So vinyl benzene, take the vinyl benzene, this is a vinyl benzene, right, okay. So to this we are adding KMnO4S. About this particular reaction we have discussed in our class also, okay. So this will be producing some compound. What compound it is? So KMnO4 under heating condition, so just remove this part and whatever the carbon here we have with the hydrogen, so convert into carboxylic acid group, COOH, yes, we got this. So COOH upon treating with NaOH plus CaO. So what is this NaOH plus CaO mixture? So this is decarboxylation reaction, right. So it means the CO2 group from benzene will be removed and forms benzene, okay. So decarboxylation taking place with this soda lime, okay. After this is our Y. So what they are asking here, so consider the following reaction sequence. Yes, so Y can be also formed from, so this is our Y, we are saying na benzene, this is our X, this is our Y. So benzene can be also formed from which of these 4 processes, they are asking like this, okay. Look here, polymerization of ethylene, what it will be produces? So polyethylene it will produce, right. So that is not the one, we require benzene. For polymerization of propane, this is also not the correct. See, aromatization of N-hexane, yes, this is correct only now. So N-hexane you can take 1, 2, 3, 4, 5, 6. So N-hexane upon aromatization, for this what we will be using? Aromatization process. So we will be using Cr2O3 or molybdenum oxides. These things we will be using around 773 Kelvin, right, okay. So at high temperatures and high pressures we will be converting this N-hexane to this benzene ring. If we take N-heptane, we will get toluene. This is the standard reactions, every time you will be seeing in the exam, frequently asked questions, these are aromatization based questions from hydrocarbons, okay. So which option is perfect for this? So aromatization of N-hexane will be giving us benzene, whereas aromatization of N-heptane gives toluene. So toluene is not given in the option, like our Y is benzene only, so suitable answer is which one? Option 3 is suitable one. Hope it is clear, right. Now let us look into the other questions also. Now the IUPAC name of the following compound, tell me what is the IUPAC name for this organic compound given? Tell me. Here we have, this is the organic compound. What are the functional groups? Here we have the OH is the principal functional group here, right. So now number it by following the least number should be comes to this OH group, okay. So I am starting from here, so let us start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes, 10 it is done, okay. So now tell me how can I give this naming? See, at 7th position bromo we have, at 5th position ethyl we have, and at 2nd position methyl we have. Bromo B, ethyl E, methyl M. So which comes first in alphabetical order? So B comes first now. So write the number as 7 bromo. Yes, 7 bromo. Okay. After this here we have E and M. E next now. So 5 ethyl. After that 2 methyl, okay, 2 methyl. How many carbons are there in total? 10, right? So decane we have to say. What is that? A decane. Okay. At 5th position we have double bond, right? So dec, methyl, dec. So continuous to that. So methyl dec, 5 in I am writing. Why I am writing 5 in? Here we have 5th position double bond. 5 in and 4 ol. So 4th position alcohol is there. 5 in 4 ol. So this is what the name for that particular compound. So just check here. So 7 bromo, 5 ethyl, 2 methyl, 5 in 4 ol. So this is our answer. So now see, there are other options also looking like that, but they haven't followed the alphabetical order. See here 2 methyl came first, after that ethyl. So this is just wrong because of this, they are not follow alphabetical order. So you need to follow alphabetical order while writing the names, then only you will get exact answer like this. Okay, hope this is also clear how we have solved this kind of question, right? Next, tell me sucrose. Observe the following. So sucrose, like hydrolysis in presence of some catalyst will be giving glucose plus fructose. So what is that? Sucrase, it means what we have, what is the enzyme here we need to use, and then next here what is the enzyme to use for conversion of this glucose. Okay, so ethanol plus water is formed. So when we will be using here, so here we will be using invertase. What is that? Invertase is an enzyme. Okay, and here we will be using zymase. So these are the two reagents we are like catalysts or enzymes we will be using for like hydrolysis of glucose to the respective ethanol plus carbon dioxide, and here glucose with invertase gives glucose plus fructose. Okay, so these also I think you will be coming across this in biomolecules as well as in your bio topics also, biology topics also, right? Yes. Now tell me here, which are the following complexes exhibit geometrical isomerism? Okay, so this is from coordination complexes. So tell me, how can we solve this question? Yeah, all of them are octahedral complexes, right? So coordination number 6 we have. So right, let us start with option number 2 first. So easy to understand. See, we have cobalt here as a metal. So around this cobalt we have 6 ligands, 4 ammonia ligands, 2 chloride ligands. Okay, so let us write the octahedral structure first. So this is what tetrahedral, square planar you are seeing now. So above this one and below this one you can understand like this. So by placing chlorine here and ammonia ligands around this plane, so what you will get here? So each chloride ions are trans opposite to each other na. So we can say this is trans isomer. What is that? It is a trans isomer. Now one more possibility what I am doing is I am placing this chloride ion here, ammonia here. So in that case we will get cis isomer. So whenever by changing the position of these ligands we will get different possible structures. Those are isomers. Okay. So now those isomers here we are calling them as geometrical isomers. Hope it is clear. This is trans isomer. Similarly we will be having cis by changing this chloride ion from here to here. Why it is cis? See, Cl are 180 degrees to each other. So here one Cl, here one Cl. So what is the angle here? It is 180 degrees. But if I place somewhere here, so Cl. So what is the angle here? We will be having 90 degrees. So whenever you have 90 degrees angle in octahedral geometry, you can consider them as cis. Okay, with 180 degrees angle you can consider it as trans. Okay, so this is trans. If you replace this or by this you will get cis. So here you have cis trans isomerism possible. Here also, so CO we have this side if you place in, see in means you can write in the short form like this, in. Okay, so chloride. Okay, so these are trans isomers. Now just replace this chlorine here and in from here to like this. So what you will get? So from this you will get cis trans isomer here also, right? Hope it is clear. So for 4 it is possible, and when it comes to this CO in, see in means all these are same. See here, I hope it is clear now. I will be replacing this with 3 ins. So in means here you can place one more in, and here you can place one more in. Like this we have 3 ins, okay, 3 ins we have. So in these 3 ins, in means what? Ethylene diamine, right? So ethylene diamine. So in this case, even if you change the places of these in bonds, there is no difference, right? Therefore geometrical isomerism does not possible in this case, cobalt En 3 times, okay. Here it is not possible for geometrical isomerism. Which isomerism? I am saying geometrical isomerism is not possible in this CO in thrice, okay. So now let us look into this one. Again here it is possible now. So cobalt we have, place this in here, okay, in I am placing here, and ammonia trans to each other, chlorine here cis to each other. So now this is a one isomer we have. Now replace these places, chlorine trans and ammonia cis. Therefore you will get geometrical isomerism in this also. So can get in this. So 1 2 4. So 1 2 4 is the answer. So option 3 is your answer for this question. Hope it is clear, right? Now let us move further. So Ziegler-Natta catalyst. What is the Ziegler-Natta catalyst? First tell me. So it is titanium TiCl4 plus trialkyl aluminum, right? Like this, okay. Or you will be seeing C2H5Cl 3 times Al plus TiCl4 like this. So this kind of composition will be there. So this is called as Ziegler-Natta catalyst. What is that? Ziegler-Natta catalyst. So what is the use of this Ziegler-Natta catalyst? It is used for polymerization. Especially it will be more useful in the preparation of what? High density polymers like HDPE. High density polyethylene will be produced when we use this TiCl4 and trialkyl aluminum. Okay. Yes. This is direct question from polymers chapter, okay. Then next here we have, yeah, so can you answer this question? Yes, so give a try to answer this. See, observe the following reactions and the order of reactivity of X, Y, Z in SN1 reaction. See, easy question, they made it 2-step answer. See, what is the in first step you need to find the products in these reactions. After that compare the reactivity towards SN2 reaction. See, what do we need to do? Remove this double bond and add this HBr. Where, how can we add this? So look here. So just remove, like HBr means H plus Br minus, right? So add this H plus here, and here you will get positive charge. Now that position you add Br. So this is your answer for first one. This is our X, okay. And here, so HCl na H plus Cl minus. So H plus if you add here, you will get a more stable tertiary carbocation here. Add Cl minus there. So you will be having ClH like this, okay. And when we are using this thionyl chloride, so what happens is just remove this OH and replace that with Cl, okay. So we have discussed these reactions with a special video of nucleophilic substitution reactions, okay. You can watch that also if you want. So now these are the products formed here. This is Y, this is Z. Now tell me their reactivity order. See, always remember tertiary alkyl halides towards SN1 they are saying na, tertiary alkyl halides are more reactive. So Y is more reactive, and this one Z and X, so both are secondary halides because chloride bromide attached to the carbon which is attached to the carbons which are there surrounded by 2 other carbons. See, this is the position of the carbon. If this carbon is attached to one other carbon, only one other carbon, then we can say this carbon as primary carbon. This carbon as primary. If it is attached to 2 other carbons, then we can say secondary. If it is attached to 3 other carbons directly attached, then it can be tertiary. Now this Z and X are what? Secondary carbon halides, alkyl halides. Now in this case, the leaving group ability of Br minus more than this Cl minus. Therefore, since the leaving group ability is more for Br minus, that will react more readily when we compare with this Z okay, in SN1 and SN2 reaction. So I can go with like this, Y, X and least is Z. So Y, X and least is Z. So our option 3 is perfect for this particular question, right? Hope it is also clear. Now you can take a screenshot if you require and give a try from your side. Then next, let us move further. This is one of the very frequently asked question. You will be seeing the same question in JEE NEET exams also. Okay, so here isopropyl benzene. What is the structure of isopropyl benzene? So isopropyl benzene is this one. So benzene ring with this group like this. Okay. Now to this we need to add oxygen. So where can we add this oxygen? Oxygen means you can write like this. Here we have one hydrogen. So the reaction happens at this hydrogen. Okay. So it will be forming a peroxy bond. You will get a product something like this. Like this. Okay. So after forming that, so this is our X. Okay. So X upon treating with water, I mean acidic hydrolysis, so you will be getting phenol as a product. Okay. Upon rearrangement you will be getting phenol as a product here. Okay. Along with that Z is there, na? Z is nothing but this methyl, like propyl group is there, na? Yes, on that propyl group you put this CO. So you will get Z as nothing but this is acetone. What is this? Acetone is our Z and phenol is our major product here. Okay. So this cumin, what we can call, this is cumin, the general name for this is cumin. So this is one of the very important method for preparation of phenols using cumin. Okay. So now what they are asking about the incorrect statement about Z. Okay. It means they are asking about this acetone. So our question is about acetone now. Okay. Look here, write the structure properly so that you can answer easily. Z gives yellow precipitate with iodoform with this is correct only, na? They are asking about incorrect one. Okay. Yes, chloroform, like whenever we are treating this with halogens, okay, in basic medium, yes, this will give haloform test because we have methyl ketones are there, na? Methyl ketones will give haloform test. Okay. So statement 1 is correct only, but they are asking about incorrect one. Okay. You should not choose this. Next, Z gives isopropyl alcohol reduction with H2 in presence of PD. Yes, that is also correct only now. Yeah, they may that will be producing what? Reduction of acetone gives what? Alcohol, right? Then next, Z on reaction with magnesium, methyl magnesium bromide followed by hydrolysis gives secondary alcohol. See, now treat this with methyl magnesium bromide, CH3 MgBr. So what you will be getting? CH3 minus, that is a nucleophile, and this is a carbon which is electrophilic center. So you will be getting this methyl attacks on this carbon, carbonyl group carbon. So it will be converting into CH3, CH3, CH3. Okay, when it is added here, this is a methyl group you can consider. Now this will be converting into alcohol. So which type of alcohol it is? See, OH group attached to the carbon which is directly attached with 3 other carbons. So we can say it is tertiary alcohol, not the secondary, but they are saying gives secondary alcohol. So this statement is incorrect, right? So option 3 statement is incorrect. That is what you need to choose as your answer in this particular question. They are asking about incorrect statement only. So your option 3 is perfect answer for this. So Z does not give positive test with phalanx reagent. Yes, so Z, that acetone, ketones will not give positive test towards phalanx reagent. Na? Only aliphatic aldehydes will show positive test with this phalanx reagent. So option 4 also correct. So the incorrect statement here is option 3 only. That is what you need to choose, right? Next. So this question we will be seeing here. We have benzamide. Okay, so which upon treating with NaOBr. So what is this process? Hoffman bromamide degradation. What is the name of the reaction? Hoffman bromamide degradation. So what happens in Hoffman bromamide degradation? So whenever you have amide group like R, CO, NH2 group is there now. So whenever you are treating this with NaOH plus Br2 or any halogens like this Br2, or simply they will give NaOBr like this. okay, or NaOX they will give like this. So just what you need to do is just remove this part. If you remove this part, what is the remaining part you have? RNH2. So you are preparing amines from this amides. Amine, this is amine, and this is acid amides. These are amides. Okay, so just you remove this CO part, add the remaining parts. So you will get primary amines as a product. Primary amines as your product. Hope it is clear. So this method, name of this reaction is called Hoffman bromamide degradation. Hope it is clear. So now in this case you just remove the CO part and add the remaining part. So what is our Y here? So that will be simple. Just benzene, remove the CO part and add that NH2. So it is aniline is our Y. Okay, what is the name of this compound? Aniline. So where do we have? So Y is our aniline. Okay, so here Y and here Y we have. Let us also find this X. So this amide, so we need to treat with this sulfonyl chloride. So benzene sulfonyl chloride. So what happens there? So we will be getting a product something like this. Okay, so this, if you want, you can write like this. This is a benzene sulfonyl chloride. Okay, so generally we will be saying it as Hinsberg test, reagent for Hinsberg reagent test. Okay, so now what happens is this NH2 group will attacks on this sulfonyl group and chloride ions goes out. So we will be having NHSO, the next like this. So this is a product up to here. Okay, so now here we have base. So base also will be having that will remove proton, and upon hydrolysis. So upon hydrolysis what happens? So upon hydrolysis, so one of this group will be leaves from here. Okay, yes, okay, wait, this side should be CO, right? This is CO group, right? So how we got this? See, this is the site attacking on this sulfur and this is going out. So this methyl group or this carbonyl group I have represented as it is. Now what you need to do? Just hydrolyze this. So if you hydrolyze that, what is the product formed? Write the product formed here. So hydrolysis gives what? So this water molecule is a nucleophile, attacks at this electrophilic center and generates what? Carboxylic acid it will generate. Okay, carboxylic acid it will be generates. So what is our X here? So it will be attacking on this carbonyl group and generating carboxylic acid as a product. So our X is carboxylic acid and our Y is aniline. Okay, so X is carboxylic acid and Y is our aniline. Hope it is clear how we got these two options, right? Yes. Now let us move further. This one last question for you. So we have C2H2. So what is mean by C2H2? This is acetylene, or you can say like this. Okay. So this upon treating with some reagent, we are getting this acetaldehyde. So in order to convert this acetaldehyde, so we can use hydrolysis process in presence of some catalyst like Hg. Okay, Hg, SO4 like this, Hg plus 2 here we have now in acidic medium. Okay, so we will get the acetaldehyde as a product. Okay, so then next I mean by adding, see, by adding one hydrogen here it will be like this. So CO, H and one more like this. So CH like this we will get. So now this is the aldehyde, acetaldehyde. So with dilute NaOH, what is this reaction? This is simple aldol condensation, right? So simple aldol condensation, what we need to use? So take this kind of molecules 2 moles. Okay, from 1 mole you remove, from 1 mole you need to remove CH2 group and other mole you need to remove oxygen. So that, see, I am writing that one only. So just look here. Like this I am writing, 2 moles I have taken. So just remove these 2 parts. Okay, so you will get the final product as like this. So this is our product. Okay, so upon heating we will get this alpha beta unsaturated carbonyl compound as a major product here. Okay, so this is what aldol condensation. Now they are asking our X is done and our Y they are asking. So how can we get this Y? Okay, it means we need to convert this alcohol to this aldehyde. So how can we convert that? So using some oxidizing agent that will oxidize this alcohol to this aldehyde. Okay, especially we need to convert alcohol to aldehyde means, so that definitely PCC is one of the reagent as per the options. If we use this KMNO4, it will further oxidation takes place. Okay, it may give carboxylic acid also, so not the correct one. Okay, and then next here we have PCC, but here along with this we required what? We required HgSO4 also, or Hg plus 2. Okay, that is not mentioned. So here it is fine, but this is not the one. Okay, and here both are correct. H2O, H2SO4 and Hg is correct, and PCC also correct. So PCC, pyridinium chlorochromate, is a suitable reagent for conversion of primary alcohols to respective aldehydes. Okay, whereas if you use KMNO4 or Jones reagent, that converts to respective carboxylic acid. So that's why these options are not the one. Okay, so option 4 is perfect. Hope it is clear, and we are done with this particular live session for today, and we will be meeting again at 4:30 p.m. for 100 days challenge for NEET, JEE and EAPCET preparation. Okay, and now you will be having physics live session on questionnaire discussion for this EAPCET. Okay, so thank you for watching. Stay connected with us. Thank you.